Hi, in this video, let us continue the lectures on section 4.5. Okay, so in this video, we would like to talk about how do we actually get from the graph of f prime and then to help us to graph the function f. Okay, so let us start with reviewing the like the first derivative test. Okay, so it said that suppose that C is critical numbers of a continuous functions f. Okay, so again, remember critical number meaning f prime of C equal to 0 or f prime of C does not exceed. Okay, again, when you have f prime of C equal to 0, meaning you have a smooth curve. Okay, when you have f prime of C does not exceed, meaning you have a sharp corner, right? For continuous functions. Okay. Okay, so we said that if f prime changing from positive to negative at C, then f has a local maximum at C. Okay. Again, based on the ID test, when f prime positive, meaning the function is increasing, f prime negative, meaning the function is decreasing. So basically, you have the function is from increasing to decreasing, right? At C, meaning now at C you have local maximum, okay? If f changing from negative to positive as x equal to C, then have a local minimum, okay? C meaning, so if f prime is negative, that means the function is decreasing in this interval. And then changing to f prime positive as C. So therefore, in this case, you will see that we have a local minimum as x equal to C. Okay. Now, of course, if f prime does not change psi as C, then f has no local maximum or minimum as C. Basically, it means that if the function is increasing and then increasing, right? Or decreasing and decreasing. Okay, so therefore we have no local max or min as C now. Okay. Okay, so then let's see. Okay, right now we would like to work on number 2. Okay, is now we have a function, the graph of f prime, and then I would like to again sketch the function f. Okay, so let's see how we actually do this type of problem. Okay, now remember in package 1, okay, so we have learned how we actually sketch the function from f to f prime, okay? So basically, first, we try to find the critical numbers. Okay, meaning is f prime of C equal to 0 or f prime of C does not exceed, okay? So basically, what we did here, we would like to find the local maximum or min, okay, of the functions, okay? So maybe so in this case right here, I found out that in this case, my local maximum is here, my local minimum is here, okay? So meaning the quick numbers here, I have x equal to A and B, okay? And then now step 2 is we would like to work with the f functions using the point or maybe the values, right? On the x-axis, x equal to A and B. And then we find out that from negative infinity to A, the function is increasing. And then from A to B is decreasing. And then from B to infinity is increasing, right? Then step 3, we change it, okay? We work with the ID test. So again, we label out the AB, the quick numbers that we have. And then if F prime is if F is increasing, F prime must be positive. If F is decreasing, then F prime is negative. Right? So we have something like this. Okay. Okay. Of course, in this case, we could say that again, this is my maximum here. This is my minimum here. So we could actually, okay, indicate that on the side charge of F prime. Okay. And then now, of course, step 4, we base on the result from the F prime, we will be able to sketch the functions. Okay. So in this case, this is actually is my y, x. And again, I would like to label A and B. So then now we have again, basically the graph is from positive. Okay. From positive to negative. And then, and of course, back to the positive. Okay. So then in this case, we will have the graph basically is look like something like this. Okay. So this will be my F prime now. Okay. So then now, when we try to work on the problem number 2, okay, we have the F prime. Basically now we have it number 4, we have F prime. Then how do we actually work it backward, right? We would like to, again, get it from F prime and then to F, okay? So then you will see that basically what is the first step? The first step is we would like to find out the critical numbers where F prime is equal to 0, okay? So then I would like to say that here, my first step, okay, I would like to find the critical numbers. Okay, to this problem. Then in this case, now again, remember this is F prime of x equal to 0. So I have F prime of x equal to 0. Then x is equal to 1 and x is equal to 5. Okay. So we actually, again, we work with this step first. Okay. And then now, how about my step 2 now? So step 2 is I would like to create the side charge. Okay. For F prime. Okay. That means in this case, I have a number line and then indicate my F prime. Okay. What I need to put it on the side charge here, I would like to put down 1 and 5. Okay, just like what we did here. And then now let us read it from the function now. Okay, F prime. Now you will see that in this case, between 0 and 1, what happened to the output? The output of F prime is below the x-axis, meaning is all negative. And now between 1 and 5, the F prime is about the x-axis. So that means this is a positive right here. Okay. And again, it is below the x-axis between 5 and 6. So it is negative. Okay. So again, this one is the positive, meaning the f prime graph about the x-axis. Okay. And then the negative mean f prime graph below the x-axis. Okay, so this is the idea. Then after we have this, then what is my next step? Okay, you will see that the next step, of course, we could change it from f prime to f now. We indicate this is the f function here. Okay, same thing. I would like to indicate, maybe write down the quick numbers 1 and 5 here. Okay. Then now we actually, the negative is mean that the function is decreasing. Okay. And then positive meaning increasing, positive of f prime, right? Is increasing of f. And then negative, decreasing again. So therefore, again, step 3 is the one that we would like to create. Maybe associated the charge for f function. Okay. Okay. Then, up to this point, we should be able to answer A and B now. So, on what interval is increasing or decreasing? So, we know that increasing is actually from 1 to 5. Then decreasing, okay. Again, to this function f, the domain of f is in between 0 and 6, right? Based on the information that we have here. So then decreasing, it will be from 0 to 1, union with 5 to 6 then, okay? Then I would like to determine, okay, the local maximum and minimum. Then of course, from decreasing to increasing, we have a minimum here. Increasing to decreasing, we have a maximum here. Okay, or we could use the side charge for f prime here, from negative to positive, minimum, positive to negative, maximum. Okay. Okay, so then now I have my local max at x equal to 5. And then local min at x equal to 1. Okay. Okay, so after we have something like this, then well, the last one is how do we sketch it from f prime to f function now? Okay, and then to this one, I would like to start with that means start a function at 0, 0, right? Because f of 0 equal to 0. Then let us do this then. First, let us draw again quantity system, right? Okay. So we have y, 0, and x here. Okay. Okay. And now I would like to put the scale on the x-axis. I have 1, 2, 3, 4, 5, and 6. Okay. So to this function f right here, let me do this, okay? So again, this one is when I try to graph the function f, okay? Then now I would like to use a vertical dash line, okay, for the critical numbers. Okay, so it means that so I will draw, okay, vertical dash line for x equal to 1 and x equal to 5. Okay. And second, I will use a straight line for increasing and decreasing. Okay, so what does this mean? Now, first of all, you will see that the function basically is, we start at 0, right? So meaning the function basically is decreasing first, okay? And then the function is so then the function is increasing. And decreasing again. Just like this. Okay. And then again, why I have this is look like symmetric with x equal to 3. The reason is you see that the original function basically it is symmetric with respect to x equal to 3, right? Yeah. Okay. Anyway, and now let's see how to actually finish the function now. Okay. Then one thing about this is first we are going to have a local minimum, okay, on this vertical line x equal to 1. And then the local maximum is on the x equal to 5 right here. Okay. Then again, remember, we just need to work with a smooth curve. Okay. So then kind of like this. And then it is, and then curve back. So I will have local maximum at x equal to 5 and local minimum as x equal to 1. Okay. Then this full curve right here is actually my f functions. Okay. Or you could actually again use this straight line as a guideline, then you could actually sketch the function this way too. Okay. It is also okay, right? With this problem. Okay. And remember, you only need one of the solution, either the bool f or the ping f. Okay.